Hi everyone, in this video I want to give you an introduction to lines and linear functions. It might be a review from Algebra 2, but it's a really important concept for us, and it's one of our most important examples of a function, a linear function. So let's start out with this equation, y equals 2x. If you stare at this for a couple minutes, it's pretty clear that for any x value I plug in, there's only one possible y value, so we know this is a function. We can study it from its function table first. So if I plug -1 into this function, y equals 2x, then I get y equals 2 times -1, which equals -2. So that tells me that the point -1, -2 is on my graph. When I plug in 0, I get y equals 2 times 0, which is 0. So the point 0, 0 is on my graph. When I plug in 1, I get y equals 2 times 1, which is 2. So the point 1, 2 is on my graph. When I plug in 2, I get y equals 2 times 2. So that's 4, and 2, 4 is on my graph. You might notice that the y values increase by 2 for every time the x values increase by 1. That's coming from the fact that we're just multiplying the x values by 2. So let's graph this function. -1, -2 is a point on the graph, 0, 0, 1, 2, 2, 4, and we could keep going, but now we just connect up the points. And what is our graph? This is a line. And by what we just observed, you can also see on this line that for every time I go to the right by 1 unit, to get to another point on the line, I have to go up by 2 units. This idea is called slope. So the idea of slope is that I go up 2 units each time I go right by 1 unit. And the way that we say that is the slope is 2. So say our line was the same slope, or it looked pretty similar, but it's just shifted up a little bit. This new line I've just drawn in, still I go up 2 units every time that I go over 1. So these two lines have the same slope, even though this one shifted up. It's just a way to measure steepness. It's like going up a mountain. So how far up do you have to go for every step forward you take? Now, this concept of slope and shifting up and down is all encapsulated by the equation of a line that we use. The standard equation, the general form, is called the slope-intercept form, and it's written y equals mx plus b. So in the example above, y equals mx, this was sort of plus 0. The b was 0 in that case. And the m was 2. That's just how we're comparing this equation to this general form. What's really special about this is that these numbers, m and b, give us information about the graph. It goes back to that idea that algebra and geometry are very much linked once we're talking on the Cartesian plane. This m represents the slope. Just like in the last example, this 2 told us how far up we had to go every time we went over. The slope was 2 for this graph. That's always going to be the case when we can write our line as y equals mx plus b. And what does this b tell us? Well, if x is 0, then this term goes away and we just get y equals b. What that tells us is that b is the y-intercept, or the y value of the y-intercept. So let's look at another example, just to show you what's going on here. So say I start at, here's my line. This is the point 0, 1, and go up 3. Let's say go over 2 to get to the next point. So 2, 3 is also on my line. Then the b is going to be 1. The y-intercept is 0, 1. That's where we intersect the y-axis. And the y value of that's 1. So for this equation, b is 1. And m is how far up I have to go every time I go over 1. So I have to go up 2 in order to go over 2. That's what we get from these 2 points, which means the same as if I go up 1, I'm going over 1. So the slope m here is 1. So to get the equation of this line, I just plug in y equals 1x plus 1, because m is 1 and b is 1. We'll do some more examples later in the video. I just want to talk about slope for another moment, and there's going to be a whole video on calculating slope that you can watch for plenty more examples. But just for the purpose of this video, let's get a little more sense. So this line, if I want to figure out the slope, I just pick 2 points on it, and I figure out how far up do I have to go for every time that I go over 1. So to get over from 2 to 3, I've gone up, so this is a unit of 1 over. I've only gone up about half a unit. So I go 1/2 every time I go over 1. So that means the slope of this line equals 1/2. We can also figure out the equation of this line because the y-intercept is given to us. It's 0, 1. So that says b is 1. So put these things together into y equals mx plus b, and I get y equals 1/2 x plus 1 for the equation of this line. Now let's do an example where we go the other way. We're given the equation and we want to come up with a graph. So the first thing I need to do is I need to put this in y equals mx plus b form. Because that will make it easier for me to graph. So the only thing I need to do to put it in this form is to bring the x over to the other side of the equation. So I get y equals negative x plus 2. To be more explicit, I could write this as negative 1x plus 2. So here's m, and here's b. So we have m equals negative 1, and b equals 2. This tells us the y-intercept. The y-intercept will be at 0, 2. And this tells us that we go down 1 each time we go right 1. So for each forward step of 1, we have to step down to get to another point on the graph. So now let's graph this using those 2 pieces of information. So first, I'll graph the y-intercept because that's a point that I know is on the graph. So 0, 2 will be right here. Now I can find another point on the graph using the slope. I know that for every time I go over by 1, I have to step down 1. So that gives me another point on the graph. If I go over by 1, I have to step down 1. Over by 1, step down 1. And now I can just connect up these points. And this is the line x plus y equals 2, which is the same as the line y equals negative x plus 2. Okay, let's do one final example. Here's a graph, and I need to find the equation. So I need to find y equals mx plus b. And all that means for finding this equation is I need to figure out what these two numbers are. I need to figure out m, and I need to figure out b. B comes from the y-intercept. The y-intercept here is 0, 1, 2, 3. And b is the x-coordinate of the y-coordinate of the y-intercept. So b equals 3. M, well, I can figure m out by taking 2 points on the graph. So I've got 0, 3. This one looks like 2, 2. And that I need to figure out how far I step down for every time I step over. So this one, if I just step over 1, I don't end up at an integer stepping down. So another way we could calculate the slope is figure out how far I have to go over to step down 2. And that fraction will be the same as what we would have gotten for if we step down 1. So in order to, every time I step over by 2, I step down by 1. So the slope m is going to be -1. That's the step down, divided by 2. That's the step over. So now I have all the information I need. I'm just going to plug it in. So y equals -1/2 x plus 3 is the equation of our line. All right, so I hope that this was a good refresher of lines and slopes from Algebra 2, and there will be some more detail in the upcoming video.